Hi, welcome to the video for the paper Adaptive Data Collection for Latin American Community Resource Evaluation of Stereotypes, otherwise known as LACES, for ACL 2026. First, let's introduce some concepts. Let's define what bias benchmarks are. They are datasets that seek to quantify biases in language models. They are constructed with phrases or scenarios containing stereotypes or sensitive context to challenge the model. Essentially, the datasets function as controlled experiments to observe how the model behaves in situations prone to revealing biases. But what's the issue here, especially since other bias benchmarks on these topics already exist? However, most of this research is focused exclusively on the English language. Many metrics, datasets, and mitigation methods are based on the linguistic, social, and cultural characteristics of English. Furthermore, most data collections rely on annotation guidelines and static examples, introducing bias from the researchers themselves. We believe it's essential that the methodology encourages the exploration of long-tail regional knowledge. We introduce LACES. LACES covers almost 5,000 stereotype associations of the format nationality attribute, as annotated by 83 individuals from 15 distinct countries. While all entries attain a minimum of one validation, a subset of over 1,250 pairs were validated at least twice. There were two data collection contexts, an in-person workshop and a virtual hackathon. Participants used our own developed tool EDIA as the central axis of their work. This is EDIA. Anyone can visit and use it for free through the link on the screen. LACES was built through one of our tabs, the Stereotype Validator. The core task for data collection consists of validating a given nationality attribute pair and extending the dataset by introducing new pairs, either by proposing a new attribute for the nationality or associating another nationality to the attribute. The input pair the user receives is selected through a weighted probabilistic model. It balances three goals: community focus, incentivizing geographically close data points to the user's nationality; validation coverage, prioritizing data points with fewer than 3 validations; and recency, favor current session data for real-time feedback. This was especially valuable for the in-person workshop, since it encouraged interactions between the annotators. It was an engaging activity filled with lively discussions. As a result, the LACES dataset was created, a dataset composed of almost 5,000 stereotype associations with validations. But what makes this dataset unique? First, it reflects in-group and out-group perspectives, reflecting whether annotators refer to their own group or to others. Given that 15 countries participated in the study, a purely random sampling approach would yield less than 7% coverage for in-group annotations. However, since our adaptive methodology specifically incentivized their collection, in-group percentages significantly exceeded this baseline across all categories. Second, you can see the agreement and disagreement across topics. We quantified inter-annotator agreement by calculating the variance of scores assigned to each unique nationality attribute pair. High variance in these ratings serves as a proxy for socio-cultural contention within a given topic. Negative traits and pop culture had the most disagreement, while geography and sports had the most agreement. Third, to further understand how social identity influences the perception of stereotypes, we manually augmented the attributes in the LACES dataset with sentiment labels: positive, neutral, and negative. This allows us to analyze the relationship between an annotator's group membership and the willingness to validate a stereotype. When participants evaluated stereotypes targeting their own nationality in group, we observed that positive and neutral attributes showed a distinct shift towards the top of the scale. This means annotators agreed the most when speaking in a positive light about their own community. Fourth, we wanted to see the thematic overlap with established benchmarks. For every entry across all datasets, we calculated the maximum cosine similarity against all entries in the comparison pool. An attribute is classified as unique if its embedding does not exceed a predefined similarity threshold with any existing record in the other datasets, indicating that the entry represents a novel thematic contribution. LACES yields the highest proportion of unique associations. This proves that our specific approach to gathering data works as we hoped. It saves time and resources, while still giving us a rich, diverse dataset. Finally, we show that the stereotypes found in LACES are especially challenging. Debiasing methods that work well on other benchmarks fail to achieve the same result in LACES. The methods are explanation and reprompting, and we compare them to a baseline without debiasing. We adopt the BBQ evaluation protocol, using multiple choice items that ask which country is associated with a specific stereotypical attribute, including an unknown option to mitigate forced choice bias. The bias score was also defined in BBQ and relates the number of biased and non-unknown predictions. LACES exhibits the highest average baseline bias across all benchmarks. The explanation approach tries to identify invalid assumptions before answering. It achieves an average bias reduction of 75% across datasets, ranging from 95% in BBQ to 61% in Seagull, but only reaches 43% in LACES. Reprompting is a two-step intervention instructing to remove bias from its initial response. It reduces bias by an average of 76% across benchmarks, including 87% in BBQ and 85% in cross pairs, but its effectiveness falls to 54% for LACES. In conclusion, the LACES project offers a twofold concrete and transformative intervention. First, to the problem of underrepresentative bias benchmarks by focusing on Latin America with in-group representation, allowing these communities to represent themselves. Second, we aim to reduce researcher bias with static and blind sampling for an adaptive methodology, where examples are created and validated dynamically by the participants involved. We believe that building these regional benchmarks collaboratively paves the way for technologies that are more equitable, representative, and conscious of the voices that have historically been marginalized or invisible. Thank you for watching.